Hey everyone, my name's Will Valida. I'm a software engineer and cloud architect, and in this video we're going to explore arrays and vector data types in Rust. So let's start with arrays. Now, Rust has several compound data types that can be used to group multiple values into a single type. So remember, in our data types video, we reviewed the tuple data type, which is useful when we want to combine different types of data into a single value. So to start off with, we're going to explore the array data type, which is a collection of objects of the same type that are stored sequentially in memory. Now, the length or size of an array equals the number of elements in the array, and the size of the array can be specified either in the code or the compiler can infer the size of the array. So, to define an array, we can define it in two different ways. We can use a comma-separated list of values where the length isn't specified, or the initial value followed by a semicolon and then the array length. So let's write this out. So first up, I've got a new project, Array and Vectors, where I'm going to be storing all my Rust code. Again, as a reminder, all of this code will be stored on my GitHub account. So let me get rid of the hello world variable. Printout line, sorry, and let's write some code. So let working days, and I'm going to use square brackets to initialize or store the content of my arrays, and then I'm going to write, this is going to be an array of all string types. So Monday, Tuesday, Wednesday, Thursday, and finally Friday. If you have different working days, I apologize, but these are my working days. Cool, so that's one way we can initialize a variable. So we've declared it, initialized all the values, and the compiler is going to infer a length of 7, the length of this array as 7. What we can also do, we can also declare an array, initialize all the values to a specific value, and then declare the length as well. So what I'm going to do is let working days num. I'll have an initial value of all values will be 0. Use the semicolon and then the array length, which is going to be 5. Not an L, semicolon, that's a bit better. Cool. Now, just a bit of information about the array signature. So at compile time, the signature of an array is defined as T size. So T, this 0 here, will be the data type of all elements in the array. So in our example, it's going to be an integer, and then the size is an integer that represents the array length. So this working days num array length is going to be 5. Now, this signature reveals two important characteristics about the arrays. So every element of an array has to have the same data type. The data type will never change. And then the size of the array will always be fixed. So the length will never change. The only thing that can change, only one thing about an array can change over time, and that's the values of the elements in the array. So the data type will remain constant and the number of elements will remain constant, but we can actually change the values within our array. Now, elements in the array are numbered starting from 0. So we use indexing to access the elements in an array with a certain expression where we will call the name of the array followed by the index. So if I wanted to print out Monday, what I can do is use the print line macro, and I'm going to use working days and use 0. So that will print out the first element in my working days array. So if I go, I'm in my arrays and vectors project directory and go cargo run. And let me use some value substitution in that. There we go. Let me run that again. Cool, and that's printed out Monday. So at position 0 within our working days array, that's going to be set to the value of Monday. So if we wanted to set that to Thursday, I could just go 3. So 0, 1, 2. Sorry, 2. I said Wednesday or Thursday. Let's print out Thursday. So that'd be 3. There we go. If I run that again, There we go. Now it's printed out Thursday. Cool. So essentially to access elements in our working days array, we use an index that ranges from 0 to the array length. So in our example, 0, 1, 2, 3, 4. So from 0 to 4. So the first element at index 0 will have Monday, and then 4 will have Friday. Cool. So one thing that we do have to kind of bear in mind is we shouldn't try and access a value that's out of bounds. So if we try to access an element in our array with an index that's not in our allowed range, we're going to get an error returned to us from the compiler. So let me try this. So if I try to access element 7, our array is goes up to 4. So if I try and access 7, that should give me an out of bounds compile error. So let me clear this, just get a little bit more real estate. Run cargo run. And there we go. There's the error returned to us by the compiler. So the index is out of bounds. The length is 5, but the index is 7. Cool, so the array length is known at compile time, and so this means that Rust makes it impossible for any program to be built that attempts to access an array with an out-of-bounds index. So that's arrays. So let's move on to vectors. Now, like arrays, vectors store multiple values that have the same data type. However, unlike arrays, the size or length of a vector can grow and shrink at any time. And the ability for the size to change over time is implied at compile time. So as a result, Rust can't prevent you from accessing an invalid position in your vector like it does for out-of-bounds arrays or access in arrays. Now, when we define a vector, you'll notice kind of like a T syntax, which represents the use of a generic type. And we'll talk about generics in a future. But we use generic type declarations when we don't actually know the data type. And this generic type syntax is actually used to declare vectors. So to actually create a vector, we use a concrete type like unsigned integers or strings. So let's actually go ahead and define a vector for us. So I'm going to declare a vector, let nephew's age. I'm going to use this vec keyword. The eldest one is 14, youngest one is 9, and the youngest is on the way, so it'll be 0. So what I'm going to do is print line that. So nephew's age. Do some value substitution. Nephew's age. There we go. Cool. So we're declaring a vector here, and we're also initializing it with the free values, which is my nephew's age. Now, like arrays, we can also declare an initial value for all of our elements in our vector. So zeros, what I'm going to do is declare a new vector, 0, that semicolon again, and then also the length of the vector as well. So I'll print that out as well so we can actually see what's going on. So zeros, and then pass through the zeros, tuple. There we go. So let me clear that. I'll make sure that I'm not accessing an out-of-bound array. Let me run that again. And there we go. So we've printed out those two vectors. So in this example, we use the : syntax with the print line macro, as I've done here. So Rust doesn't really know how to display a vector of integers. So if we try to display the vector information without using special formatting, the compiler is going to issue us an error. So we use the empty curly parentheses to help kind of display the vector values. Vectors can also be created using the vec new method. So I can, let me go mute names. So this is going to create an empty vector, and I'm declaring it as mutable. So if we were to use it over time, we can enable it to grow and shrink. So the way that we can actually do this, once we've declared this, we can push to add values. We can push values into this new vector using the push method. So I'm going to add some names to this. So will names.push Isaac, names.push, and Samuel. Oh, Sam, there we go, cool. So I'm pushing some names into my vector. So then if I print line that, names, there we go. I'm going to format it and just write out the names. There we go. So, well, let me clear, get some real estate going. Run that. There we go. So there are my names printed out. So there are all the quotation marks around my string values. So there is my vector of strings. Now, after the vector is set to a concrete type, only specific values of that specific type can be added to the vector. So if I try now, names.push add 1, and I run that, I'm going to get a compiler error. There we go. So it's going to expect a string, but instead I passed a mute, passed an integer. So what I'm going to do is just remove that. There we go. Cool. Cool. Now, to remove values at the end of the vector, what I can do is I can actually use the pop method. So what I'm going to do now is just go names.pop. And then I'm going to print line that. And then what we should see is that Samuel has been removed from our vector. Samuel, if you're watching this, this is not special treatment that I'm giving to your older nephew. This is just for a demo. There we go. So Sam is now removed from our vector of names. Cool. I'll leave that there for now. So vectors also support indexing in the same manner as arrays. So we can access element values in the vector by using an index, where the first element is index 0, and then the last element will be the length of your vector minus 1. So let's use another example. What I'm going to do, let mute, and I'm going to just declare a new vector of fruit. So apple, banana. I'm going to say melon. I can't spell. It's terrible. And then orange. There we go. You can have a laugh at me and my spelling. Okay, so if I let orange, I won't use capitalization there, and I set that to the index of vector 2. So now what I want to do is print line. I'll print the vector. And I'll just pass through my fruit and then also my orange variables there. So if I run that, hopefully that compiles okay. Nope. I've got the semicolon there. Let me try that again. What's going on here? I'm not actually using the name of my vector. There we go. Make sure everything's okay. There we go, cool. So it's print out my vector finally of my fruits and also set orange to orange. Fantastic. Now, because vector values are mutable, we can actually change a value in place by accessing the element value in the index. So, for example, if I wanted to change the first element to a strawberry, what I'll do is I'll actually put that line there and see how it changes the output. So cargo run, Cool, so rather than apple being printed in our original vector, we've now used the index of our vector to change it, that value to strawberry, and then strawberry gets printed out. Cool, so that's fairly straightforward. Now, with arrays, we can't access an element in a vector with an index that's not in the allowed range. So this is a type of expression for an array that causes the compiler to return an error like we saw before. Now for vectors, it's a little different. So your program will compile, but the program will enter an unrecoverable panic state at the expression and then stops the program execution. So let's actually see this in action. So let not in fruit is equal to fruit. And I'll set the index to 100 because I like being silly. And I'm going to try and print that out. Not in fruit. Cool, so let's see what happens. Okay, so most of the program compiled. The program did compile, but the program actually aborted this time. And we can see the thread panicked at line 30. Index out of bounds, the length is 3, but the index is 100. And it throws this error. In a future video, we'll look at how we can actually safely recover from programs using a program panic. But for now, we just need to know that with vectors, you can try to attempt to access an element that's not within your vector bounds, but it is going to panic and throw this error. Cool, so I'm just going to go ahead and delete that line. So that wraps up this video on arrays and vectors in Rust. We learned first about arrays and how they're a collection of objects of the same type that are stored sequentially in memory. We also learned that every element of an array has the same data type, the data type will never change, and the size of an array is fixed, that the length will never fix. The only thing that can change about an array is the values of the elements in the array. We also learned how we can actually index into an array to access a particular value within an array, and we also learned what happens when we try to access out of bounds index values. We then moved on to vector data types, and we also learned that vectors are different to arrays where they have the ability to change its size over time, and which is in part at compile time. So we learned how to push new values into a vector. We also learned how to remove values from a vector using the push and pop methods. We also learned that a difference in vectors compared to arrays when we tried to access an out of bounds index value, that the compilation will pass. However, the program will enter an unrecoverable panic state at the expression and will stop execution if we try to access an out of bounds index value in a vector. If you like this video, give it a like. If you want to learn more about Rust, don't forget to subscribe. In the next video, we'll start to move on to different types of loops, so for loops and while loops. So I hope to see you there. No matter where you are in the world, I hope you're having a great day, and we'll see you all next time.